Everyone, welcome once again to this online chemistry class for standard 10. We are doing this chapter, that is chapter number 4, carbon and its compounds. See, for this chapter number 4, we have already discussed the topics that are omitted, right? And you can refer the NCERT website for the same. But in my previous video, I have spoken about saturated and unsaturated hydrocarbons, covalent bonding, and why is carbon considered to be a versatile element? Because I felt that there is no harm in learning certain basics. These things will help you in your higher classes. Okay, so when you're talking about structural formula, you should know about saturated and unsaturated hydrocarbons. But in your syllabus, it is clearly mentioned that the difference between saturated and unsaturated hydrocarbons is not included. But you should know about what are saturated and unsaturated hydrocarbons as you are learning the structural formula here. Clear to you? So only from the point of view of giving some basic knowledge to you about the element carbon, I have spoken about those things. But as far as your examination is concerned, you can strictly stick to what is mentioned in the syllabus. Once I complete the lesson, I will once again present the slides mentioning the topics that are included from this chapter for your board exam. Okay, now let's get into today's session. Let's now start with chains, branches and rings, which is mentioned in your textbook. There is a table given in textbook page number 64, that is table 4.2. In that they have mentioned the name of certain carbon compounds like methane, ethane, propane, butane, pentane and hexane. They have given you the molecular formula for the same and the structural representation for the same. And these structures can be in the form of straight chain, what we call as linear chain. They can be in the form of branches or in the form of rings. Okay, now methane, the molecular formula is CH4. So how will you write the structural formula for this methane? See, formula is CH4. From the formula itself, you know that it has got one carbon atom. Every carbon atom has 4 hands. So every hand should be connected to one hydrogen atom. So this is the structural representation for methane. Next is ethane. The molecular formula for ethane is C2H6. So 2 carbon atom, right? One end of each carbon atom is linked with a carbon atom itself. So the remaining 3 hands of these carbon atoms will be connected to one hydrogen atom each. So 6 hydrogen atoms and 2 carbon atoms. This is the structural representation. Similarly, propane is C3H8. So when it is C3H8, 3 carbon atoms are there. C3H8. So 3 carbon atom. Every carbon atom is linked with each other. So the remaining hands of these carbon atom. First carbon atom will have 3 hands. Second carbon atom will have 2 hands left because other 2 hands are connected to carbon atom itself. Last carbon atom again has 3 hands. So every hand should be connected to hydrogen atoms. So you have 8 hydrogen atoms and 3 carbon atoms. So this is the structural representation for propane. Similarly, you can easily draw the structural representation for butane. So you have to memorize the formula for the same. So when you know the formula, it is easy for you to write the structural representation. Okay. So these are the basic fuel gases which consists of hydrocarbon like methane, ethane, propane and butane. Okay, now there are 2 more things given in your textbook under table number 4.2, which are pentane and hexane. So pentane formula is pentane, 5 carbon atoms, pent. So 5 carbon atoms, so every carbon atom has 4 hands. So when you join the carbon atom, 5 carbon atoms with each other, whatever hands are left for each carbon atom should be linked with hydrogen atom. So C5H12 is the molecular formula for pentane. So the structural representation for pentane is also mentioned here. Similarly, the structural representation for hexane is also given here, and hexane molecular formula is C6H14. So you have to know the formula for methane, ethane, propane, butane, hexane, pentane and hexane. Methane 1 carbon atom, ethane 2 carbon atom, propane 3 carbon atoms, butane 4 carbon atoms, pentane 5 carbon atoms, hexane 6 carbon atoms. So when you link these carbon atoms, whatever hands are there with the carbon atom, remaining hands of carbon atom should be linked with hydrogen atom. So when you know the formula, CH4 methane, C2H6 ethane, C3H8 propane, C4H10 butane, C5H12 pentane, C6H14 is hexane. So please memorize the molecular formula. When you know the molecular formula for these hydrocarbons, that is methane, ethane, propane, butane, pentane and hexane, you can easily draw the structural representation. Just connect the carbon atom as a straight chain, and the branch means the hands, the remaining hands of the carbon atom will be connected to one hydrogen atom each, every hand of the carbon atom that is left. Okay, so practice these structural formula even. Okay, now let's learn about a concept called structural isomers. Okay, before doing that, see, let us take the example of butane. What is the molecular formula for butane? It is C4H10 is the molecular formula for butane. Now, when you look at this, you can make the carbon skeleton with 4 atoms of carbon. So that skeleton can be formed in 2 different ways. One, a straight chain like this, and another one, like you can connect branches to it. Either this way, or you can follow what is mentioned in the example shown on the slide. Now whatever hands of carbon are remaining can be connected with one hydrogen atom each. And when I take the straight chain here, when I connect hydrogen atom to that, this carbon atom remaining 3 hands here, this 2 hands of carbon, because second carbon atom has 2 hands linked with each carbon atom here, and here I have 2, and here again I'll have 3, right? So this is one way. So 3 plus 2, 5, 6, 7, 8, 9, 10. So this is what is mentioned here. This is what is mentioned in butane, right? By taking a linear chain. Now, when I take a branched form of the same, like when I take the other structure, like what is mentioned in your textbook, formula is again C4H10. So when I take the other way of writing the same thing, like 3 carbon atoms forming a linear chain, and then now I have to form branches here. So this carbon atom will be linked to 3 hydrogen atom. Here 3 hands of carbon has already gone. So one hand of carbon will be connected to hydrogen. This carbon atom again 3 hydrogen atoms. And this carbon atom will have again 3 hydrogen atoms linked to it. So this is the other way of representing the structure of butane, which has the same formula C4H10. So one more pattern is given in your textbook, that is like this. That is 3 carbon atoms, 2 carbon atoms linked in a straight chain, and then this way. So now what happens here is, I'll give the 3 hands of carbon atom present here to 3 hydrogen atom. This carbon atom has 3 hands connected to 3 other carbon atoms. So one more carbon atom hand should be connected to 1 hydrogen atom. So this carbon atom's 3 hands will be given to 3 hydrogen atoms. Again, this carbon atom will have 3 hands given to other 3 hydrogen atoms. This is mentioned in your textbook. Okay, so when you represent the compounds with identical molecular formula with different structures, you call them as structural isomers. Okay, so what are structural isomers? They are compounds with similar molecular formula but different structure. Okay, so when I form a linear chain using 4 carbon atoms, we call it as butane. When I represent the same molecular formula C4H10 in a different way by giving branches to it, then I call it as a structural isomer. In that case, I call it as isobutane even. Understood? So you should know what is a structural isomer. They are compounds with identical molecular formula but different structure. Okay, so both the structures mentioned here for butane and isobutane have the same molecular formula, that is C4H10. Clear to you? Studied the straight line structure and branch structure of arranging carbon atoms. Now there is one more pattern which you have to learn, that is ring like way of arranging carbon atoms. So this cyclohexane stands as an example. So here the carbon atoms, the 6 carbon atoms in cyclohexane are arranged in the form of a ring, and the hands of these carbon atoms are connected to hydrogen atoms. So C6H12 is the molecular formula for cyclohexane, and the electron dot structure for cyclohexane is also mentioned here. Please make a note of it. So next comes the structure of benzene. By looking at the structure of benzene, easily you can make out which structure is it representing, whether a straight line structure or a branch structure or a ring like structure. Okay. All these carbon compounds which contain only carbon and hydrogen are called hydrocarbons, and these hydrocarbons are of two types, that is saturated and unsaturated hydrocarbons. And among these saturated hydrocarbons are all called alkanes, and your alkenes and alkynes come under the category of unsaturated hydrocarbons. Okay, so today we have studied the structural formula and the molecular formula of certain hydrocarbons like your methane, ethane, propane, butane, pentane and hexane, and we have learnt the way of arranging the carbon atoms in the form of a straight line, a branched form and ring like structure. So with this we are coming to an end of today's session. Meet you soon in the next class. Till then, take care. Bye.